In this lesson, you will learn about assigning geometric constraints. This is a very important aspect of the software that you need to understand thoroughly. Your mastery of this topic will help you to set up progressively more complex engineering challenges. So the underlying constraint manager in CAD Calc and GraphicCalc has been specially developed for function modeling. We did this development from the ground up. We wrote perhaps as much as 1 million lines of code and threw them away to find out the final code that will allow users to capture their design's functional intents using a simple point and click process. So every geometry in every entity in CAD, Calc, and GraphicCalc can be constrained using geometric constraints. To show you the principle, whenever you create an entity, you create by defining points. These are point constraints. And when you create the geometry, you can see that it leaves the 2-point constraints that were used for defining the geometry. Likewise, when you create a circle, you can see that these are the 2 points that you clicked. And when they're free, you can change them. But each of these points can be allocated what we call geometric constraints. So let me delete this. The most common way of allocating constraints is using the inference method, when the software can infer the nearest available constraint. And this is under the control of the right mouse button. You can turn the infer engine on or off. And when the infer engine is off, the constraint starts snapping. So let's go very quickly through what are the constraint types that are available. This is called the free point. That means there is no constraint on the geometry. This is the origin or the centroid or the center of a circle or the origin and centroid of a shape. This is the endpoint of an entity. It can be a line or an arc. This is a proportionate constraint. That means you can allocate a geometric constraint for a point to be at a certain percent along an entity. So for example, if you constrain a point to the midpoint of another entity, it'll be at a 50% point. This is a tangent constraint, and this is the intersection constraint, where two entities intersect, maybe line to line or line to arcs or line to circles or arcs to arcs or any two entities intersecting. This is a virtual intersection. That means the two entities, if they were extended, they would join. And this is called point on or slider entity. That means the point will stay along an entity. It'll stay on an entity. It may slide on an entity, but it will stay on the entity. And these are some preset constraints for convenience purposes that can be allocated to lines which are parallel, perpendicular, and at a specific angle to a line. So let's very quickly go through these constraint types with real examples. So for example, if you have a circle, then this would be at the center of the circle. This is allocating the constraint to be at the center of the circle. If you had a shape, let's say, let me make this into shape. Then if I say that make it at the center of the shape, this is constrained to the centroid of the shape. And as the shape changes, the point is moving. This, of course, is pretty straightforward. This is, let me turn off the infer switch so you can see how the constraint is working. This is endpoint of this line, or the endpoint of this line. Now this line is constrained. The 2-point constraints are constrained to the endpoint of the line. Notice whenever I click on a constraint, I get a feedback from the constraint. It tells me that it's an endpoint constraint. It also tells you endpoint in the message bar here, and the endpoint is highlighted here. If I interrogate this constraint, it tells me it's an origin or centroid constraint, and it's the centroid of this shape. You can see the binding boxes, and the centroid or the origin constraint is highlighted. So this way you can interrogate any constraint and find out what that constraint is. So if I wanted to give a percentage constraint, I say make this point at the 30% of this line, and you can see now that this will be at 30% of this line, and if this point changes, you will notice that it always stays at 30 points. So the percentage is decided on which side of the line you are clicking. For example, if I took the same line and I say make it at 70% of this line, and I click here, it'll come back here. If I say same line 70% and click on this side, it'll constraint on that side. So the next constraint is a tangent constraint, which is you have to locate a point and then you say tangent, so it'll stay tangent to that entity. And let me just select all and clear this. Let's draw two situations.